All right, so it says an airbag applies a force of 1,200 newtons, and the change in momentum, remember that change in momentum is, in our physics class, we call that impulse, is 32 kilogram meters per second. Okay, how much time did it take to act? Okay, so J is, just a quick refresher, this is what we call impulse. We use J for impulse because we used up all the other letters. Okay, well, what is that equal to? Well, that's just equal to the change in momentum. In fact, impulse is just change in momentum. And as we stated in problem number 4, that's also equal to a force applied over time. And it's also equal to, remember that J is also equal to the mass of the object times the change in velocity, right? Because the mass never changes. The only thing that can change is momentum. But we're picking this one because, whoops. We're picking this one because it has two things. It has change in momentum, it has force, and it has time. While this is our force, in other words, if I were to label things, the force applied is 1,200 newtons. And I should probably point out that there, the way it's worded, it's a constant 1,200 newtons. Like, it doesn't ramp up or slow down. And then our change in momentum, or impulse, is 372 kilogram meters per second. So I'm just going to plug that in. I'm going to say 372 kilograms meters per second. And I wonder if it'll let me, nope, it won't let me select the whole thing.
You just have to drag.
Yeah. I think the problem is I'm using this fancy pen there. We'll do this. We'll slide that over a little bit. Okay. When I use the fancy pen, it moves the whole thing. All right, so then that is equal to our force, which is 1,200 newtons. Now, if you don't remember, newtons, right, is force, but it's also the mass, so it's kilograms times acceleration. So my newtons is kilogram meters per second squared. So this will be kilograms meters per second squared times delta t. So when I divide this by 1,200 kilogram meters per seconds squared, and I got to do the same thing over here, 1,200 kilogram meters per second squared, these units will cancel out. So let's make that red. So this kilogram cancels with this kilogram, meters cancels with this, meters cancels with this cancels with one of these. And then because you're dividing by a fraction, this comes up on the top. So really, what I'm going to end up with is the 372 divided by 1,200 seconds, which is what we want because we're solving for a time. So I'm going to say 372 divided by 1,200, hit enter, and I get 0.31. Oops, here we go. So I'm going to get 0.31 seconds. And then everything over here cancels except for delta t. Now I gotta check the answer. If you use scientific, well, let me look. If you use significant figures, sometimes they round it. Did they do 0.3? No, they left it at 0.31. Yeah, 2. Okay. Yep. So that's the correct answer. Any questions on that? Okay, good. Does that make sense?